Right, sketching polynomials. Things to keep in mind. If you want to draw a rough sketch of polynomials, and remember at this stage we're talking about without calculus, so those turning points, exactly where they turn, for now, we'll just guess. But once we know calculus, we'll be able to identify those points exactly. The y-intercept is, of course, always the constant, so that's an easy point to plot. So let's do that with this one. You don't have to expand it out, of course, because to work out the overall constant, it's always got to be the constants times the constants. So in this one, it's going to be 1 times negative 1 cubed times 2 squared, which is equal to negative 4. So we'll plot that point in. Okay. The x-intercepts are the roots. So if it's easy to find, I will. Now in this case, my one's already factorised, so finding the x-intercepts will be easy. So I will plot them. Okay, I'm going to have minus 1. The next one will give me 1, and then the other one will give me minus 2. As we are out at the extremes, the polynomial will act like the leading term. Because what happens in a polynomial, the leading term dominates, is the technical term. So as you substitute in bigger and bigger numbers, it's like all the other terms doesn't matter. The leading term takes over, and so it acts just like that. Well, that lets us know where we start the polynomial and where we finish it. All right, so what is the leading term? Again, I don't have to expand the whole thing out. I can just look at the leading term of each bit. And I'm going to have x times x cubed times x squared, which is x to the power of... Now, if I asked you to draw x to the power of 6, what would you draw? A U shape, okay? Remember, only the x squared is a parabola, but so it's U shape. So it'd be like this. So I know this one will start up here, finish up here. Now, let's have a look in those x-intercepts in more detail, the roots. When they're factorised, so the roots will act like the factor. So if it's an even power, then it will come down and touch it. Like if it's squared, a parabola, or if it's 4, it'll do that. Now we've got x plus 2 squared. So over here at negative 2, I know it will touch like a parabola because the power's 2. I also know it's coming down from up here, so therefore the curve is doing that at minus 2. Well, odd-powered roots also will look like that inflection type thing. Other than power of 1, I mean, power of 1 will just come through like a straight line. Okay. So over here at 1, we got to the power of 3. So it's going to come through like the cubic. But I know it finishes up there, so it'll come through like that. Okay. That actually is what the curve ends up looking like. I'll say, to find the actual turning points, we need a bit of calculus to find those. But for a rough sketch, I mean, we'll just turn them wherever and so on. Okay. Now, if you can factorise it completely, then basically you've got the basic curve shifted. So if you could just complete it all and go, oh, x minus a to the power of 3 or whatever, you got your cubic shifted and so on. Let's solve this inequality then. X minus 1 squared x plus 3 is less than or equal to 0. Again, I'll just use the graph. Here's my axes. I know I've got an x-intercept at 1, and I've got one at negative 3 as well. They're, in fact, the critical points of this inequality I want to solve. I know the graph's going to look like that. Now, how do I know that? The leading term, x squared times x is x cubed. So starts down here, finishes up the top there. I've got a double root at negative 1, so it touches it like a parabola. I'm not concerned about the y-intercept because I'm just solving for x's here. Now I just got to look at that graph and say, oh, well, when is it below 0? When is it below 0? All right, well, it's equal to as well, so those points are included. When is it below? There. So my solution is x is less than or equal to negative 3, but also x equals 1. It's equal to 0 over there at 1. Be surprised if people forgetting that single point. They had a similar question to it in the HSC once, and that was a big mistake people made. Because it was a single point, they didn't include it in the solution. Okay. 3B.